Hello, everyone. Welcome back. I hope everyone had a delicious lunch. I realize it was a little crowded in the dining hall, but I hope everybody can get seated and ready for another exciting session of the Horizon Cloud Summit. My name is Mark Dietrich. I'm with the EGI Foundation. I'm part of the Horizon Cloud Project, which is sponsoring this event. And today, right now, we have a great session, which is going to be about success stories and use cases from the European cloud community. And our moderator is going to be Angel Giuliano, who is the CEO of Across Limits, a Malta-based organization which she's led since 2001. And Angel has been involved in Europe-wide innovation and business growth for many, many years. So, Angel, over to you.
Thank you, Mark, and welcome everyone from different parts of Europe. We're very happy to be here today to really share with you different success stories and use cases from the European cloud community. As Mark said, as part of Horizon Cloud project, we have collected quite a catalogue of all of these wonderful success stories, which I will remind you also to visit after this session. But what we're going to do here today is listen from 4 of these success stories that come from different parts of Europe. So without further ado, I would like to invite our first speaker. This is going to be Riccardo Vitorino. And Riccardo, the floor is yours. Thank you.
Thank you, Angela. Thanks everyone for joining today's session. I hope you can hear me well. I'm head of innovation at Ubiware, and we typically develop software solutions for smart cities. We are based in Portugal, in Aveiro, concretely, and we have been working with different cities all across Europe. And today I'll explain a little bit about our product roadmap and actually one use case from a European project that we are coordinating called For Protect. So I'm sorry that the slide is not properly rendered. So we have solutions in more than 60 cities worldwide, not just in Europe, but also in the United States, from bike sharing systems to smart parking to traffic and air quality monitoring. And our value proposition for cities is that we can not only provide these vertical solutions, but we can actually help them seeing the city as a single integrated system, meaning that they can see the different domains in a single map. And our proposal for that, our value proposition, is that we can see the city as an organic approach, with an organic approach, so that we can map and analyze what's happening at the street level, just like our human body typically handles information, which is through the nervous system. So our nervous system in our human bodies is responsible for transmitting signals to every part of our body and efficiently coordinate our actions. And it's composed of a central part and a peripheral part. And we aim to do this in the same way with cloud solutions that handle the central part of the nervous system and having street furniture that's connected on the peripheral nervous system. So if we start with peripheral nervous system, we might be aware already that there is a lot of street furniture available at the smart city level. So we have street lights across the streets that can do a little bit more than just provide us lighting, which helps with accessibility and safety. But we can also then enable a modular approach for sharing this infrastructure and allowing for different models and use cases and business domains to be implemented and provided for the community while enabling proper sharing of the infrastructure. So we can enable 5G connectivity or Wi-Fi connectivity, different types of sensing of Internet of Things through cameras and sensors that can help monitor the parking occupancy, the traffic flow, air quality and noise. We can enable EV charging for electrical vehicles to become charged in specific points. And more than that, enable new business models that enable this infrastructure sharing between multiple providers. And then we have the central nervous system, so the brain of the city, where all the data comes into the single place and allows decision makers to make the best out of it. So on the one hand, we would be able to see exactly the different domains that the peripheral nervous system can monitor. So we would be able to see in real time the status of what's happening at the street level. having information on mobility, environment, energy, ensuring that we can understand the parking occupancy, the correlation with the traffic flow, analyzing the environmental impact, and not only being able to see everything in a single map, but actually filter it out and navigate through the data and see how it evolves along the time. So to compare with historical patterns and historical behavior. And further than that, part of this information can actually from the community, so we can involve citizens to participate and provide feedback to the decision makers. And here we are able to understand specific problems or incidents that have happened at the street level and ensure that the city can properly respond, finding the best team closer to the incident, providing the proper response, but actually have this communication channel with the community and ensuring that ensuring that the privacy of the data is secured, being able to communicate with the community and understand what are the current challenges and how to better respond to them. And here we can provide attachments of photographs of what's happening at the street level and see the perfect location of the incident. But that's not all. So we also have customizable dashboards that allow for KPI analysis. So analyzing the performance of the city regarding the mobility, the environment, and actually analyzing the parking occupancy along time and seeing how it's being affected by traffic, getting different KPIs and different insights that support data-driven decisions, and allowing for this correlation of information to be used by different data scientists, by different teams at the city level, and ensuring that this can be used then for further forecasting and impact assessment. Last but not least, and according to the United Nations, cities are feeling a lot of pressure to meet their sustainable development goals. Indeed, there are a lot of goals that they need to comply with, and through the international standards organizations, there are two benchmarks. So the 37120 and 37122 that monitors the KPIs of quality of life and sustainability. So for us, it's very useful to support cities benchmarking themselves and see how they are evolving along time, but actually giving them this standard approach of comparing different cities in different member states or regions using the same type of indicators. Most of them wouldn't require a platform like ours, but the environmental impact, the infrastructure usage, the energy consumption, it's something that changes from day to night, from summer to winter, and it's something that should be compared and assessed a long time and not only once a year, as typically these surveys can collect. So all of this is made possible thanks to an open architecture that complies with best practices from the European reference architectures, from the European Innovation Partnership on Smart Cities and Communities, Open and Agile Smart Cities, and also FIWARE Initiative and Big Data Value Association, where best practices on architecture can enable data exchange through standard approach, and data is harmonized into common data models. So you are able to see that the different sensors and data sets that are provided in the city can be processed and analyzed by our platform, and then these insights and dashboards can then be customized and make available for third parties to use through open APIs and open interface. This is, of course, to help cities become more sustainable. And one concrete example of a city that's working together with us is the city of Guimarães, who has been considered a best practice by the European Commission, a study led by Gartner within the European Location Interoperability Solutions for E-Government framework, because of the urban platform being co-created and developed together with the city, and ensuring that the cities don't have to have all the data on their own at first, and can further integrate it as we go, as we move forward, as their digitization roadmap evolves. And we are very happy to promote that it's been selected by the Portuguese government to be the World Summit Awards government and citizen engagement representative of our country. So we won at the national level, and we hope that we can further receive awards with this solution because it's part of our flagship roadmap, and we are very, very happy with it. But we are not stopping here. So we spoke a lot of data collection and from the street furniture to the cloud. But indeed, some of this information is sensitive, right? So we cannot just deploy CC cameras and collect information at our own will. So we have this European project from the Horizon 2020 that we are coordinating. It's called Fog Protect, which aims at protecting sensitive data in the computing continuum, meaning from the edge, from the street level up to the cloud. And there are multiple challenges that help that promote this. And on the one hand, our use case aims to demonstrate that we can protect sensitive information at the street level using the peripheral nervous system that I just mentioned. So in this image here, you see that you have two street light poles, one of them with the CCTV capturing video streams for parking analysis, for traffic flow observation, for detecting any incident that might be happening in that area for the city to monitor. And on the second lamppost to the left, you'll be able to embed computing units and network connectivity to collect this information and process it before sending it to the cloud. So this unit over there will be blurring the sensitive information like people's faces, the license plates, and then only sending the blurred video to the cloud and all the metadata that were retrieved. And the Fog Protect aims at doing more than this. Our use case is responsible for this part, and we will be demonstrating it in our headquarters in Aveiro, Portugal. Here you can see on the top the CCTV camera that's currently being used and the computing unit that's processing the video. And besides identifying parking occupancy in our headquarters and detecting anything, we are already blurring this information. But the use case goes much beyond that. So as we process this information and ensuring that in our urban platform, only specific policy levels can access this information and can see. So we would have different roles accessing different types of data. So an urban planner could only see metadata retrieved by the video. The traffic analyst could see the blurred video and analyze the video without any sensitive information. And the police officer with a certain mandate could see the proper raw information in order to assess if an incident occurs, that he can see who was involved and how to properly support them. So ensuring that this computing continuum is properly protected. And if there's anything happening wrong with the lamppost, since it's at the street level and could have an accident or climate conditions could disrupt it, we would be able to find computing units and ensuring that the data can still be protected and processed without too much of a downtime and harming the operations of the city. And this is part of our research and innovation roadmap. For us, we are here for the long run. The UbiWare has been founded in 2007. We are now 14 years old, almost 100 people working. And our roadmap here is to help cities and regions become more connected, enabling this real-time data collection and analysis, collaborating with them for tailor-made results and for optimal results, and ultimately to improve traffic flow and reducing greenhouse gas emissions to make the world more sustainable, to make cities with a better quality of life as part of our mission. I'm really thankful for being able here to share today. If you'd like to know more information about Fog Protect, UbiWare, and our smart city products, feel free to reach us at innovation@ubiware.com. And thank you so much for your attention. I'll be happy to connect in LinkedIn and follow up via email. Thank you so much for being here today.
Thank you so much, Ricardo. That was really great because it's really a practical application in cities where most of us live. And of course, very much in line with the new European Green Deal policies. So I really hope that many of you in the audience are going to make contact with Ricardo as well. Now, something I forgot to tell you is that you can definitely ask us questions. And at the end of all the 4 presentations, we're going to have a bit of time to answer a few burning questions. So please remember to write your questions in the chat. So let's now go to our next speaker. Now we have Sebastian Geller, Senior Software and Embedded Developer from Eiken Technology and Process Consulting. Sebastian, you have the floor.
Thank you, Angela. Welcome to my talk. My name is Sebastian Geller and I work for Eiken Technology and Process Consulting. I'm the product leader for Eiken Platform and I will present today the Eiken use case and its influence within the EU Morphemic project. For 30 years, Eiken has been the globally trusted partner for computational fluid dynamics, short CFD, engineering applications. We are more than 100 CFD simulations experts in the group and deliver on-premise, cloud, and cloud-based CFD products and expert services with the targets to be better, faster, cheaper, and easier on the market. Eiken products and services are used across a wide range of industry CFD applications, including automotive, aerospace, building, manufacturing, and many others. The automotive sector itself consists of a wide range of applications, such as fecal water management and soiling, climatization, thermal management, and aeroacoustics. Focusing on aerodynamics for the design, numerous variants can be defined to set up different simulations, different flow engines or wind tunnel turntable positions, different ride heights, or different morphing solutions for the geometry. All of this leads to a significant demand on computing resources. Eiken Platform is a digital engineering cloud platform that provides a simulation management solution for industry. Eiken Platform enables cost-effective exploration of ideas and possibilities from the early design phase. The target is to simplify workflows. With a simplified application view, the inputs needed for a simulation will be defined. Other best practice parameters are hidden for the end user. After setup, the different cases are scheduled to compute on remote assigned hardware. In CFD terms, they are meshed, solved, and post-processed. The results are then sent back to be evaluated in the client's browser front end. This screenshot gives you an example of the setup for an easy wind tunnel application. In the left image, you can see the minimized settings required, such as the speed and wind tunnel turntable position. In the center, there's an interactive geometry view, and on the right, the geometry tree. The right image compares the 3D results of a Formula 1 racing car and a passenger car. In the next slide, you can see the chart, parallel coordinates, and image comparison views, which are nowadays state-of-the-art views to support the evaluation or decision process. Here we show how we used to compute traditionally before we started with the European project Morphemic. There was the front end to prepare and analyze the cases, the server with the database for geometries, users, groups, and results, and the directly assigned remote high-performance computing cloud facility. Let's look at what has changed with Morphemic. With Morphemic, we can have computing resources on any cloud provider on demand. We can ensure the delivery of the results within a given deadline, for instance, 24 hours. With our use case, we have defined 3 different subcases based on the computational mesh behind, which directly reflects the hardware needs. With Morphemic, the needed workers will be provided proactively. Furthermore, with the polymorphic adaptation, we ensure the best hardware, CPU, GPU, or FPGA is available, adapting to the needs of the application related to performance and cost. A significant aspect is to define the deployment configuration once and apply it to different clouds, such as AWS, Microsoft Azure, or OpenStack variants. In this slide, I will go into more detail about our application. We have a scheduler containing the front end and 3 different types of workers, with the range of cores associated. In the middle, there's the Morphemic server, which deploys the components and gives us the needed worker resources based on the optimization applied. Looking in more detail at the submissions, the incoming simulation jobs are rescheduled to specific worker queues. If the incoming simulation jobs may not be completed by the deadline with the current workers, Morphemic adds additional workers. This slide shows the formula, which is defined within the metric model of the CAML, a cloud modeling language specification. Different sensors on the scheduler and worker send information about the new job, like its estimated effort on the baseline machine and the deadline, and from the workers their specific efficiency. There's the constraint that the estimated time for an incoming job is smaller than its deadline. If not, a reconfiguration is started to add new workers. Here you can see the utility function, which is used within the optimization framework of the Morphemic toolset. At this stage, it's quite a simple utility function, which takes into account the number of workers and the cost to find the best ratio of workers and related cost. We will further evolve this function within the ongoing project. As we are reaching the end of the presentation, I gave you a short overview how our company benefits from using Morphemic. We meet the targets mentioned in the introduction to be better with dynamic exploitation of multi-cloud environments, to be faster to ensure the simulations are done in a given time frame, to be cheaper as it's optimized with the most cost-efficient cloud infrastructure, as well as easier. It's all in one configuration to deploy on different cloud providers. All of them are important components for the backend of Eiken simulation, data management, and exploring platform. Thank you for your time. And if you have any question about the topics presented, Eiken or its products and services, please do not hesitate to get in touch. Thank you.
Thank you so much, Sebastian. Once more, this is again a really useful, success story that you are presenting to us, because I'm sure that many of our listeners have a lot of issues with multi-cloud environments. Okay, let's now move on to our next speaker, and this will be Professor Radu Prodan from the University of Klagenfurt. Radu, you have.
Hello, everybody. Great to meet you. My name is Radu. I'm with University of Klagenfurt in Austria, and I'm talking about our approach on a cloud-agnostic blockchain as a service for social continuum. So our use case is social media. Why social media? Well, it's probably the most widely used type of application, the most widely used use case worldwide. More than 4 billion people, 40% of the population worldwide is using social media. We still have so although it is the most distributed application worldwide, we have an ironic situation that existing solutions are centralized. We see companies like Facebook, Google, Twitter, LinkedIn holding monopoly, centralizing the entire platform, and of course raising privacy security concerns with respect to data management and infrastructure provisioning. Additionally, we have malicious users and content. We see bad things like trolling, cyberbullying, hate speech, catfishing, astroturfing, false fake information, spamming, flowing fast on social media. Disinformation, it's something very bad that is happening today. And these are very recent examples that I'm putting on these slides. A lot of type of disinformation happening, like misleading content, false context, impostor content, manipulating content, fabricated content, satire, parody, conspiracy theories, propaganda. We can have long discussion about them if you want. So Articonf is a Horizon 2020 project, and it stands for smart social media ecosystem in a blockchain federated environment. It's a 4.2 million euro project. It ran from 2019 until next June. So we are in the last part of the project, and the call we run is on future hyperconnected sociality. Klagenfurt, my university, coordinates together with other 8 partners. So what is Articonf? Well, it's a platform as a service for decentralized applications. So we raise the abstraction and we talk here in terms of decentralized applications, so applications that do not run under central control. We build a complete toolkit for implementing such applications. We have a Hyperledger fabric as means of decentralization, so the blockchain backend underneath. To operate as a service, we need a connection to clouds, to fog, to edge. So that's why we are here. We are cloud agnostic. We support OpenStack, but also other cloud providers. And in addition, we build a lot of advanced services for community detection, community reputation, rewards, also fake news detection, and other aspects. We also have guided analytics, trying to understand what people can gain by interacting with each other in terms of social applications. Now, in terms of application, we have 2 areas. We have on one hand collective business applications. So here, in some sense, we aim to bring the business where it used to be centuries ago, in the Middle Age, where no big companies existed. People went to the good old market and exchanged goods on a peer-to-peer, person-to-person basis. Here we have car sharing as a new form of taxi, where, so for example, an Uber without an Uber company in the middle, where people simply share cars as consumables, or energy marketplace. So households are becoming producers and consumers of energy. Of course, green energy providers, and we build an energy marketplace where they can trade energy excess and need without a greed company in the middle holding monopoly. But today I will discuss about two other applications, crowd journalism and video opinion discussion. So, the crowd journalism is it's also known as collaborative media, participatory journalism, democratic journalism, guerrilla journalism, street journalism. It's a new alternate and activist form of news gathering and reporting. It functions outside of the mainstream media institutions, and it responds to shortcomings in professional journalism and media news in general, which polarizes often the society like we see today. They use similar journalistic practices, but they are driven by different objectives and ideas, more close to the people. And they rely on alternate sources of legitimacy than traditional mainstream journalism. So in our application here, for example, citizens play an active role in collecting, reporting, analyzing, and disseminating news. And you have event organizers that set up such a decentralized application, for example, to a certain event, like in a football stadium or at a certain event happening somewhere in the world. You can be geo-constrained here. It means that only people that are really part of that geolocation can stream information. So this way you filter other impostors, and people basically have the freedom to have them to democratically watch, discuss, and rate news videos in a decentralized social network. And we also build a news marketplace where people can access, buy, trade, rate, reward videos. The video opinion discussion, the next use case, is basically a complement to the journalism, where basically we help to build quality content.
There is too much noise. Digital discussions are struggling all over the world. Fake news, spamming, cyberbullying, and trolling. What is the solution? Let's censor free speech? No. Let's create genuine open conversations for the 2020s. Real people, real faces, real reviews. We live in the age of broken trust, so dialogue is more important than ever. At Vialog, our mission is to fix online discussions with video. Vialog is a tool for everyone. You only need a device with a camera. We provide an easy-to-install widget that enables video dialogue around any website, event, or topic that matters to you.
In Articonf, we work with 7 European partners to reintroduce trust with blockchain in a decentralized social media model.
Vialog was also introduced in Cine Europe, Barcelona. We spend 50 minutes every single day watching videos on our mobiles. But most of our online discussions are still text-based. And that's where Vialog comes in.
You can literally ask anything you want, like anything, but please be mindful.
Black Night, an A-list film festival with 80,000 attendees, used Vialog. It opened up a new form of dialogue between filmmakers and the audience. And this is how it worked. Check it out.
Hi everybody.
Hello.
Hi there. Forget about the Irishman, forget about the Joker. Come and watch Looted.
This is my own love letter to my mother.
It's gonna make you think, it's gonna make you laugh.
If you all have any questions whatsoever, please feel free to ask me.
We are waiting for your question.
We hope to see you all there.
It was awesome, thank you.
Perfect.
So my question is,
I would like to ask, how did Christoph convince you to feature in his movie?
He was neighbor and he saw me in a movie and he asked me, let's work together.
When she started to cry, I cried too, and too much.
I like that you cry. It's the right emotion to have after watching my movie.
And now, it's your turn. So, I have a question for you. Are you ready to discuss?
Follow us to get updates of the Articonf project and see how Vialog is developing innovative.
And finally, once we've seen this video opinion discussion promotion, I'll show you how we are able to tackle fake information on the Articonf using the Smart service, which apparently doesn't have a video. So anyway, this is our success stories in the Articonf project. So with the crowd journalism use case, we cover 2 events. the Jungfrau Marathon in Switzerland with over 200 streaming participants, over 6 hours of coverage, and over 500 YouTube channel views. And we recently covered in Porto Jump Around Hip Hop event, and the analytics of this event are currently in progress. With the video opinion discussion use case that I've just presented, we covered. Actually, it's more than 12. We are 15 video opinion discussion communities with discussion managers. We aggregated over 3,000 social video opinions in very relevant topics to the current society. Basically, we cover academic freedom in Hungary, education, knowledge exchange, equity, diversity, inclusion, digital device, employability, political elections, and many others. And recently, we started a campaign on climate positive action commitments, which we call COP commitments. You can see that link, and you can go there and basically share your opinion over the many streams of discussion that we are offering. And we are also part of the event organized by the Extinction Rebellion. And this basically concludes my talk. I thank you, everybody, and I will be open for questions.
Thank you so much, Radu. That was really inspiring and interesting. Maybe in a future event for hCloud or one of our, collaborative events, we might actually use this new system that you have built. Okay, we now are to our fourth and last panelist, but I remind you that at the end we will answer some questions. We've seen some questions come in, but please continue to pose them, and then at the end we will read them out and discuss them together. So our fourth speaker is Uwe Herzog. He's a program manager at Eurescom. So Uwe, please, you have the floor.
Thank you and good afternoon, everyone. I'm Uwe Herzog. I'm program manager at Eurescom. We are located in Heidelberg in Germany. And I'm currently coordinating the charity project, which is an EC-funded project in the Horizon 2020 program. And the charity stands for Cloud for Holography and Augmented Reality. And in my presentation today, I'll briefly introduce one of the use cases that we look at, which is the Holographic Assistant. Okay, advanced media applications that enable immersive communication are becoming quite ubiquitous in our lives today. Maybe not exactly in the form as you can see here on the photo which we have taken at our recent project meeting. However, still there is a global trend to adopt virtual solutions in order to support the day-to-day operation in businesses, social events, but also in private lives and for the general lifestyle. And the COVID-19 pandemic has given this, I think, a very strong push due to the need of having safe social interaction. And therefore, with our project activities, I think we are also contributing to addressing one of the major societal challenges that the people have in the world today. So some of these immersive communication applications include virtual reality, augmented reality, or holography, but they come with a number of challenges, and they have some strong requirements, for instance, on network connectivity, latency, but also regarding the computational power and performance that is required on the user terminal side. The virtual reality concept itself is not really new. I think it's for many decades that people think about it and started building application. And you can see here on this chart from left to the right how we can move from a real environment towards, in the end, a virtual reality environment with several iterative steps in between. However, we haven't seen so many of these being widely spread so far. And I think the main reason for that is that the technologies have simply not been that advanced so that this could have easily happened. For instance, networks, etc., processing mechanism, user equipment, displays, and so on. But with the recent developments, for instance, with 5G mobile communications that now provide much better bit rates, but also much more reduced latency. Also cloud technologies and many more. They offer now technologies so that I think we are at the start of a potential widespread take. Okay, before we go into the holographic assistant, I'd like to show also briefly the other applications that the project is working on, and we have grouped them in 3 major categories. We have the real-time holographic applications, for which we have a holographic concert, holographic meeting, that's relating to the picture I've shown at the beginning, and then the holographic assistants, which I'll on the next slide address in more detail. In the second category, we have the immersive virtual training with VR medical training, VR tour creator, and finally the mixed reality interactive application. We have a collaborative gaming and also a manned or unmanned operations trailer. And let's move on finally to the holographic assistant, which I think is, in my view, one of the most promising use cases that the project is working on. What is it? So this holographic assistant is a visual system where a 3D avatar appears on a holographic 3D display to offer assistance for daily tasks. And this assistant can interact with people. People can, for instance, ask for information, for weather, stock, ask for advice, or just talking, asking for help, etc. I mean, you can imagine there can be many types of applications for that. And it could be used also in many places. I mean, here you see on the photo the example from an airport, but you can easily guess that could be used as well in hotels, for education, in hospitals, in public administration buildings, and maybe even at homes. Perhaps not with the same type of display as here on the photo, but with a smaller handheld devices, one can easily imagine. This can also become a very popular application. The information that is used in order to responding to user requests can be sourced either from the internet, but you can also imagine that there can be some private case-specific databases from which information is taken. Okay, let's look a little bit more into the implementation of the assistant without going too much into detail. You see on the top left this user who is asking for help, and the display, the holographic display with the assistant who is going then to respond. Technically, we'll have modules located locally at the user, but the majority of functionality will be in the cloud. And these are functions, for instance, for the rendering, for the logic of the actual service, for the assistant logic, to process the 3D point cloud, etc. The service logic therefore runs independently from the capabilities and the resources of the end user device. And the information and services that the assistant offers are accessed via API interfaces that are provided by potentially various information providers. The big advantage of such an approach is that at the end user device, only the visualizing of the resulting 3D data that is received as a streamed 3D point cloud is needed. All gathering, processing of information, and rendering, compression is offloaded to the cloud, which is a big advantage because it enables a service that the user device could potentially not provide, or the network could not transfer to the user with the current capabilities. Some more technical details. Yeah, I think what I wanted really to emphasize is that the development of the use case started from scratch. There was no pre-existing application that we just wanted to make cloud native. So this is a real original innovation, and we are confident that this was also never done before in such a constellation. We are not aware of that. And the figure here on this slide shows the interaction of the software modules to orchestrate such a use case. And as mentioned before, and as you can see here again, we have some modules that are located at the user and some at the cloud, potentially the edge cloud or more on the central cloud. And when the user makes a request, the request is recorded, sent to the cloud, and then the processing is taking place there. So then the 3D data would be rendered in the cloud and then streamed with in the form of a 3D point cloud back to the user device. And then it's just to display the image and to also provide the audio. To conclude my talk, I think XR interaction can really revolutionize all aspects of our life. I think the future importance of XR application in their different characterization, VR, AR, or holographic interfaces can, in my view, not be overstated. And our use cases that we address in the project are just samples, which have maybe a very high potential impact, but that all remains to be seen, and the future will show us. What I think is also important, finally, to mention that XR application need a powerful cloud architecture. I think only with a powerful processing in the cloud, such demanding services can be implemented, and therefore this is a really essential capacity that is providing and enabling the path for XR application. On the very last slide, I'd just like to show again a brief overview of our consortium. You can see the organizations that participate in this work, and they are located across many countries in Europe. Thank you very much. That's all from my side. I hope you enjoyed the presentation.
Thank you so much, Uwe. Indeed, I think this is what the future will be like, all of these wonderful XR holograms and assistants everywhere. Now, we are coming to the question and answer session. We have already a few questions which we're going to put to our panelists. And I still, invite you to continue asking questions. So the first question is for Sebastian. Sebastian, can customers use their own compute resources as part of your worker pool? Do you resell the bare metal capabilities of cloud providers? And are you using any EU CSPs? So basically, it's 3 questions in one. So let's start. You have the floor. Tell us.
Yeah, thanks. Yes, also our clients can use their own cloud infrastructure and HPC resources, as well as it's a big security concerns many times, and we offer also to install the whole platform on the client's hardware itself. So that maybe lead to the next question. As on this, it's not much reselling the bare metal capabilities of the cloud providers, and also for European cloud service providers, we are not using any commercial one. We have some test beds on academic, but yeah, that's we don't use any European cloud service provider at the moment. Thanks.
Thank you so much. So I'm sure if from the audience we have some representative of some European cloud service provider, I think, make contact with Sebastian. Let's go now to Radu. Radu, we have a question on Vialog. How does it filter out video disinformation or fake videos?
So by design, Vialog is video-based, yeah. So first of all, you have to show your face in order to be able to contribute with an opinion. So impostor content, like being able to hide under a fake identity is by design impossible. Another thing is, of course, we establish a marketplace of videos where people basically can rate each other. So we use a classical reputation mechanism, community detections, where basically people can appreciate or disappreciate certain content, and basically through democratic consensus mechanism, basically the community regulates itself in a democratic way.
Okay, thank you, Radu. Thanks for that. Now, I'd like to ask a question to Uwe. Uwe, you've told us towards the end of your presentation, that you need powerful cloud. So since, in fact, we are talking about cloud, edge, and distributed resources, how much bandwidth and local processing ability is needed to make the charity concept work?
Mm-hmm. For the local processing capacity, this should be rather small because we outsource the more demanding and performance requiring parts of the service to the cloud. Therefore, the user device basically just need to be capable to display the holographic information. It gets information in the form of a point cloud, and that then needs to be put on the holographic display, which is not so demanding. Regarding the network KPIs, for in terms of latency, it's in the scope of milliseconds, but definitely not below. Rather, I mean, it needs to be seen, but I'd say rather in the range of tens of milliseconds in terms of latency. And regarding the bit rate, I think with the point cloud we have again enabled a lower need for bandwidth. And in the end, again, it needs to be seen once we completed everything. But I'd say it's in the tens of megabit per second that would be needed reliably for providing a simple holographic image. But in the end,
Okay.
it depends on the resolution, etc. So not a direct, easy answer.
No, I'm sure not. So we have a last question also for Ricardo. Ricardo, you showed us your solution, but how smart do cities need to be already in order to work with your solution? Because you showed different, sensors and systems, and many of the cities are maybe not too smart yet.
Yeah, that's a very good question. And well, indeed, the definition of smart cities are, well, communities that are aware of their own specific challenges and use ICT technology to solve those challenges. So in a way, any city can implement our solutions. We do not require specific dimension or level of technology readiness specific to implement. We are actually very happy to sit down with them and see what are the current challenges, the local context, and find the best solutions. Because, for instance, the smart parking monitoring could be done with CCTV cameras, but on a specific set or weather conditions or geography might not make much sense, and we might rely on magnetic sensors, for instance. So we have that sort of expertise. And when I mentioned Guimarães as the best practices, was exactly that we work directly with the city by integrating the best technology that fitted their needs and solved their challenge, and they actually helped us on the validation of the data. So there were specific insights on traffic management that were being incorrectly monitored, and it was thanks to the local context and the real knowledge of the city that even though they didn't have many sensors, many data sets at the beginning, they were able to create some, and by doing that together with us, they were able to validate. And I think that's a great example of a smart city that is able to take the best out of it.
Thank you, Ricardo. And with that, we conclude our little Q&A session. So now we pass back to Mark.
Thank you, everyone. That was really great and very exciting, because I think we're beginning to get a glimpse of what the future might look like built on the cloud and the edge and the cloud edge continuum. So a very exciting session. Now, we'll wrap up right now. In 1 hour, roughly 1 hour and 10 minutes, we will reconvene for our closing session, where two colleagues from the Horizon Cloud Project, Dr. Faka and Dr. Ramasa, will provide a bit of a wrap-up and a summary of all the sessions that we've run in the last day and a half. So it should be very interesting and a great perspective on a very complicated and a fast-moving subject. So I encourage you all to rejoin us in a little while, and I look forward to further conversations with all of you. So enjoy a little break, and we'll see you soon. Thank you.